Ladies and gentlemen, my name is Auston F, and I'm part of the Challenge 2016 program. Today we have an initial value problem. It looks like this. We have dy dx is equal to 10 minus x. And we're given the initial value of y0 is equal to -1. This is what the given information in the problem is. Now, what they want us to do is they want us to take the integral of this function, and they want us to use this initial value information to find c. Because remember, whenever you take an indefinite integral, you have to add the plus c at the end. Never forget that. So first, you take the integral of both sides. So the integral is the symbol here, right there. And so the integral of dy dx is just y. Because think about it, you're going from the initial function, right, which is y, and you're going to f prime of x, the derivative of y, and if you want to go even further, you're going down to f double prime of x, and so on and so forth. So this way I'm just going backwards. So instead of going down from the original function, this is equal to f of x, by the way, I'm going from f prime of x back to f of x. Same thing as here, because this is also equal to dy dx. Okay? Alright, so as I was saying before, you take the integral of this, which is just y. You take the integral of this, so you have a constant here, or constant, and so you just add an x to it. That's the only thing I have to do. I just add an x. So you do 10x. Now here, those of you who remember the product rule, those of you who remember the power rule, this is just the opposite of the power rule, basically. So you add 1 to the exponent, you have an imaginary exponent of 1 already. So you add 1 to this exponent, so you end up with x squared. Alright, over to the side here. So you end up with x squared, and then you divide by that exponent. So you end up with 1/2 x squared. And also, if you want to check yourself to make sure you're doing the right thing there, you can just take the derivative of that, going backwards again, you're going from here to here. So I take the derivative of this, and I get 2 times 1/2, which is just 1. And so I get x, which is what I had originally here. So I know that this is the right integral of this. Okay, so then we go over here. And we have 1/2 x squared. So you have y equals 1/2 x squared. And whenever, like I said earlier, whenever you're doing the antiderivative, or the integral of something, you have to add the plus c at the end. Okay? Alright, so now we have this function here. Y equals 10x minus 1/2 x squared plus c. So now we plug in the initial value they gave us, which is y of 0 is equal to 1. So this is the x value, basically, put it in parentheses up here. This is x. And so you plug in the -1 for y. -1, right here, just like this. Is equal to, and then 10 of 1 here. And plugging 1 here as well. Pardon me, back up a second. Our initial x value is 0 here, so we're not plugging in 1, we're plugging in 0. Minus 1/2, 0, squared plus c. Now what I'm going to be doing is I'm going to be simplifying this and solving for c so we can get that c value, plug it back in this equation. So I get -1 equals, this is 0 minus 0. So I just have the c left over. So I have c is equal to -1. So I take this equation, my original function, all the way down here, and I end up with y equals 10x minus 1/2 x squared minus 1. And that is the correct answer. Now again, all we did here is we took the antiderivative of this function, the integral of this function, and we ended up with this function here using the initial value that was given. And also just a small syntactical note, if your teacher's kind of a stickler for math syntax, as I like to call it. You want to put the function, the part of the function with the highest power first. So the teacher is really a stickler for math syntax. You'd put it like this. You'd say y is equal to, just switching this around, -1/2 x squared plus 10x minus 1. That's the only difference you can get. Alright guys, that's all we have for today. Thank you very much for watching. Have a great night.